deck is the same deck. The ship has not moved to a different ocean. The aircraft are the aircraft that flew this morning, and the catapults are the same four. But everything you can see has been rearranged. The lights are down, the colors are gone, and the whole surface is running on a different set of rules. That is the first thing worth getting straight about night flying on a carrier. It is not the daytime cycle with the lights switched off and everyone being a bit more careful. It is a separate mode of operating the deck, with its own lighting, its own signals, its own timings, and its own crews. The ship changes state. Start with the strangest part because it explains most of the rest. The deck goes dark on purpose, not dim by accident, not badly lit because nobody got around to it. Deliberately, systematically dark, with the working light cut down to a fraction of what a lit road surface would have. That darkness is the design. The reason is the human eye. Adapting to darkness takes a long time, the useful part of it around 20 to 30 minutes, and the last of it longer. Reach that state and you can read a deck by very little light indeed. Take one bright white light straight in the face and you are back at the beginning. So night vision is treated the way fuel is treated, as a resource with a quantity which the ship can spend or preserve. Every white light on that deck spends it for everyone standing in the beam and everyone facing it. The cheapest way to protect 100 adapted crew members is not to switch the light on. What is left is dim and colored. Low red and low amber over the working areas, deck edge lighting reduced to markers, and light aimed down at surfaces rather than out at faces. It is enough to walk by and work by once your eyes have caught up. It is nowhere near enough to read a face across the deck. Meanwhile, the aircraft go the other way. In daylight, an aircraft on deck is the darkest thing in the frame. At night, it is the brightest. Position lights, formation lights, lit panels, a shape you can locate from across the deck. The surface hides itself and the machines on it announce themselves. That inversion is deliberate. It makes sense once you ask what has to be seen. The deck does not move, and the people who work it know where everything is. The aircraft do move. They weigh 20 tons, and their engines turn. The thing that can hurt you is the thing that gets the lights, and everything else gives up its share. Now take the system the deck runs on in daylight. Every job out there is a color. Yellow directs aircraft, green handles catapults and arresting gear, purple fuels, red handles ordnance, blue drives tractors, white inspects. In daylight, you look at a shirt and you know what that person is allowed to do. It works because you can see it. At night, none of that reads. Under low red and amber light, color is the first thing your eye loses. A yellow shirt and a green shirt at 20 feet are two gray shapes of the same size. The most visible organizing system on the deck simply stops delivering information the moment the sun goes down. So it gets replaced, and not by one thing, but by four. Light in the hand, position on the deck, the sequence of what happens next, and a level of familiarity with the routine that lets a person work out who somebody is from how they are moving. Together, those cover most of what color was doing. The light in the hand is the visible half. Wands, illuminated batons, small lights clipped to a vest or a helmet. A director signaling an aircraft at night is not a person making gestures. He is two bright points moving through a pattern, and the pattern is the same one his arms make in daylight, drawn in light instead. Which is why those signals are worth learning as shapes rather than as poses. A daytime signal that depends on which hand is which, or on where a person is looking, does not survive the transition. The ones that survive are the ones you can still read when all that remains of the human being is the light he is holding. Position does the next part of the work. On a deck this size, the useful stations are fixed. A spot beside a catapult, a spot at the elevator, a spot where an aircraft is taken over from one director by the next. Stand there at night and you have already told the deck most of what your shirt used to say. Then there is touch, which is not romantic, it is procedural. Chains and tie-down fittings are found by hand. Panels are latched by feel and confirmed by pulling on them. A fueling connection is seated and checked the same way it is checked in daylight, except that the checking hand is doing what the eye would have done. All of that only works because the same routine has been walked in daylight, over and over, by the same people. The daytime cycle is not merely the productive part of the day. It is also the rehearsal that makes the dark part possible, which is why a crew that has not flown days recently is not sent straight into nights. Subscribe. Moving aircraft is where the change in tempo shows first. A tow that takes a few minutes in daylight takes noticeably longer in the dark, with more people walking beside the aircraft and pulling it, each one watching a wingtip, a wheel, a clearance to something parked nearby. Nothing about it is rushed, and nothing about it is meant to be. Fueling follows the same pattern. The hoses are the same hoses, and the sequence is the same sequence. But every step that daylight lets you confirm with a glance now needs a deliberate check, done close, often by hand, sometimes with a light held right against the fitting. The work is not different, the rate is. Then there is the part everyone thinks of first, which is bringing an aircraft back aboard. In daylight, a pilot on approach has the entire ship as a reference. A hull, a wake, a deck, an angle, a horizon behind all of it. The eye assembles that into a picture almost without being asked. At night, that picture is gone. What is left is a small arrangement of lights on black water, with no horizon behind it and nothing around it for scale. The ship is not a shape anymore. It is a pattern, and the pattern has to be interpreted rather than simply seen, which makes the approach a different task with the same name. So the aids carry more of the load. The optical landing system that gives a pilot his position on the glide slope is the primary reference by night, rather than a confirmation of what the eye already knows. Talk from the ship increases. Instruments are worked harder. The margin that daylight quietly provided has to be built out of other things. That is also why night landings are counted separately. A pilot is not simply qualified to land aboard. He is current for day landings and current for night landings, as two different things, each with its own recent count. Let the night number lapse and the day number does not cover you. From there, the crewing follows on its own. If night is a distinct qualification, it is also a distinct pool of people who hold it, and it tends to be the more experienced end of the roster. Not because the dark demands heroics, but because it demands that fewer things be worked out on the spot. The same logic sets the tempo. Night cycles are planned smaller and slower. Fewer aircraft in a launch, longer intervals between them. More time allowed between an aircraft landing and the deck being ready for the next one. The number that changes is not the difficulty, it is the throughput. And that slower rate is written into the schedule in advance, not discovered on the night. The plan for a flying day has the night portion budgeted at its own rate, with its own gaps. A ship that planned nights at daytime speed would spend every night quietly falling behind its own timeline, which is a planning failure, not a deck one. Up in the tower, the change is mostly one of information. By day, the people running the deck can watch it. By night, they are working from radio calls, from lights, from status boards, and from the sequence they laid out in advance. Supervision stops being a matter of looking out of the window and becomes a matter of tracking. The bridge darkens too, and for exactly the same reason as the deck. Interior lighting drops to red, screens come down in brightness, and doors to lit spaces get treated as a problem to be managed. The people conning a ship at night are protecting their own night vision as carefully as anybody outside is protecting theirs. Everywhere else in the ship, the pattern repeats at a smaller scale. Passageways that lead to the weather decks are darkened. Doors are opened in a way that does not spill light, and anyone stepping outside has already spent time getting their eyes ready. It is a habit that costs almost nothing and buys back 20 minutes of adaptation. The physics of the flying itself does not change at all. The ship still turns into the wind to launch and recover, still holds a course that gives the deck the airflow it needs, and still gives up its freedom to go where it wants for as long as aircraft are moving. Night does not soften that requirement. What does change is how much of that gets confirmed by eye. Wind, sea state, and the position of other ships are read in daylight, partly by looking. At night, the same picture is assembled from instruments, from reports, and from the discipline of keeping everyone informed, which is slower and has to be allowed for. The changeover between the two modes is its own event, and it happens at dusk. That is the point where the deck is neither lit nor dark, where colors are draining out of the vests, but the lights are not fully useful yet, and where the crews that will run the night are already out there getting their eyes ready. Watches turn over inside that window rather than at the edge of it. Handing a deck over in the dark means handing over what is spotted where, what has been fueled, what is tied down, what is unserviceable, and what the next cycle expects, spoken aloud and confirmed, because none of it can be checked with a glance afterwards. Night shifts also run longer than the daylight ones in most schedules, and that is a choice rather than an oversight. Every handover in the dark costs time and creates a moment where two people have a partial picture. Fewer, longer watches mean fewer of those moments, so the ship trades tiredness against continuity deliberately. Below, the hangar keeps its own clock. Aircraft that flew in the evening are worked on through the night so they are available in the morning, which means the maintenance floor is at its busiest while the deck above is at its quietest. The ship does not have a night. It has departments taking turns at having one. Put all of it together and the shape of the thing is clear. Darkness is chosen. Light is rationed. Color is replaced by light in the hand and position on the deck. The approach becomes an instrument task. The tempo drops on purpose, and the schedule is written to expect all of that in advance. None of which is done for the sake of doing it the hard way. It is done because a ship that can only operate between sunrise and sunset is available for about half of the time it is at sea, and half a carrier is not what the carrier is for. Night capability is the whole point of the arrangement. It is paid for in throughput and in people. The same number of sorties takes longer and occupies more of the crew for more hours. That cost is understood, it is planned around, and it is accepted every time the ship keeps flying after sunset instead of shutting the deck down until morning. So the honest way to describe a carrier at night is not a darker version of the day. It is the same steel and the same people running a second, slower, quieter system that was designed alongside the first one, and that everybody out there trained for in daylight precisely so it could be used in the dark. And through all of it, day and night, one structure on the starboard side has been running the whole thing, the island. A tower a few meters wide, holding the bridge that drives the ship, the station that controls the deck, and the watch that never stops. Who sits where in there, and why it is on that side, is the next one.